Let's go to the next slide and talk about the agenda. We're going to talk about line ratings and forecasting to start. And then I want to speak a little bit about the Watt Coalition, talk about line rating methodologies, and then get into the FERC NOPR and comments and concerns and issues related to that. I want to talk about why it really matters and then drill down on some dynamic line rating data case studies. Please use the Q&A for questions, and we've got experts here to help answer the questions if I can't do that. So let's talk about forecasting on the next slide. We use lots of different models and statistical approaches to determine our load forecast and demand requirements, and they vary across time, and it's really important to get these right. And it's not just the load, it's also on the resource side, where we have wind forecasts that are really dependent upon weather patterns. So let's go to the next slide. Let's talk about what we forecast and what we don't. Clearly, renewable energy production is forecasted, and people have good ideas of thermal plant outputs too, based on forecast and experience. Same thing happens on the load side, where we forecast the load patterns and we commit resources to serve those obligations. But what about the grid, the piece that holds this all together? Let's go to the next slide. Many things affect the capabilities of the grid. The wind, the temperature, whether it's colder or warmer than forecasted or typically used in rating calculations, whether there's cloud cover or rain. Let's go to the next slide. So these things vary too, right? The capability of the grid is dynamic. It changes every hour, every day, yet we use typically static ratings. I'm going to talk about that some more, as well as ambient adjusted ratings. Before I do that, I'd like to just give an introduction and shout out to the Watt Coalition on the next slide. So the Watt Coalition is working for advanced transmission technologies. And in my new capacity with Grid Strategies, I've been honored to work with them and do several case studies and help put on things like this just to increase the dialogue and understanding about technologies and what they can do to the grid. So Ampasian, Lindsay, and Line Vision are going to help us today. I don't know if WinSim is on the line, but they focus on dynamic line ratings. New Grid focuses primarily on topology control and optimization. Smart Wids, Smart Wires focuses on power flow controllers. Let's go to the next slide. We've got a couple links in here for future reference. Well, I'll skip the slide I'm parting, but we'll stay on this one. Let's just talk about line ratings. So there's 3 different categories of line ratings. There's static line ratings, ambient adjusted, and dynamic line ratings. Static line ratings are typically used in utility operations, and they reflect near worst case values based on assumed weather conditions. They may be based on the conductor limits of 75 to 100 degrees C for emergency operation, and ambient conditions such as 90 degrees F average temperature, full sun, no clouds or rain, and things like that. In addition, static line ratings typically are differentiated by season. There may be a summer rating as well as a winter rating. And for each of those seasons, there may be normal and emergency ratings. And maybe even short-term emergency ratings that could be used in operations. In addition, we're going to talk about ambient adjusted ratings. And this is typically a static rating that has been updated to reflect different or actual or forecasted ambient temperatures. It doesn't necessarily take into account the other key parameters that affect the line's capabilities. Now, dynamic line ratings are calculated and updated in real time, and they take into account all the variables that affect the capacity of the conductor. And what you'll see on the diagram to the right are some of the key parameters that affect the rating and capability of a line. So you see the losses on the line, the resistive heating, the I squared R factors, as well as the convective cooling. And that is typically the most important parameter for the capability of a conductor. The solar heating and radiative curve of the line is other factors that need to be considered in terms of the actual rating. For static line ratings, key assumptions are made about each of those. And sometimes they're assuming 2 feet per second wind speed, maybe 3 feet per second. But you can see an increase of a few feet per second can make a huge increase in the capacity of the line. So wind cools the conductor, which allows much more power to safely be transmitted on that line. On the next slide are the references I mentioned earlier. You may want to look at these links. Back in the summer of 2009, DOE published a dynamic line rating report to Congress. You may want to look at that, as well as the Watt Coalition comments that were provided to FERC in response to the managing line rating notice of inquiry. The last link here is a blog that I put out on November 18th, which was the day that FERC voted and approved the NOPR on managing line ratings. That actually wasn't posted in the Federal Register until a couple of weeks ago, but so we have 60 days to provide comments, and we're going to try to use this forum to go over at least some remarks and talk about key issues. So please add questions, and we'll try to get those addressed as we go along. To start, we think that the NOPR is a step in the right direction. The Commission has proposed to, quote, to improve the accuracy and transparency of transmission line ratings. This upgrade is long overdue, as it applies to the electric transmission grid. We need better line ratings to get better grid operations. Let's move on to the next slide. Talk a little bit about why this matters. I guess before we do, I'm jumping ahead. Here's some comments that have been made by market monitors, as well as key utilities and regulators. You can see that Potomac Economics says that line ratings are one of the most important issues before the Commission and the best opportunities to make improvements to the efficiency of the market. AP commented that this was the subject matter and the timing could not be more apropos. I've never used apropos in a sentence until this presentation, and I didn't know how to spell it. So, but OMS provided some comments too about all the benefits due to better ratings, and that consumers are harmed when ratings do not reflect actual capacities, and leads to higher energy prices, as well as increased congestion and suboptimal operations. So this is just a subset of some of the comments made by some of the folks involved in the NOPR and the development of the record. Let's go forward to the next slide and talk about why we think this falls short. The NOPR is a step in the right direction. As I mentioned, it makes modest advancement over standard static line ratings by requiring broader use of ambient adjuster ratings, but it does not require dynamic line ratings where it's appropriate. Dynamic line ratings, as you'll see from the presentation later, can materially satisfy customers' demands over a given set lines or individual lines. One of the biggest concerns we have about AAR is that it ignores key factors that affect the line capacity, which introduces significant inaccuracies. And AARs could result in line ratings being actually higher than what is being used in operations. And that results in a lot of inefficiencies to the grid. In addition, AARs could be actually higher than the true capability of the line. And that would be a reliability risk and safety concern. So we need to address those. So let's talk about why this matters and why good ratings are really important. If you've kept up with the transmission studies that have been done recently, looking at decarbonization of the economy, you see that the transmission capacity needs to increase by a factor of 2 to 3 times above the delivery capacity system to support bulk power needs, low carbon resources, to provide access to least cost resources, to meet utility goals, customer preferences, and public policy. Accurate line ratings can increase the use of the existing system very quickly and a very low cost. And you'll see some examples of that later, where these devices can be deployed, and reused and moved around as congestion moves on the network. Transmission system is very dynamic. The grid has prices that change every day and congestion points that move all the time. So it's important to have devices that can forecast that and take advantage of that, of the capability of the system based on very accurate line ratings. Let's move on to the next slide about why it matters. Accurate line ratings also reduce the cost to customers. Line ratings that are accurate increase the efficiency of the system, reduce production cost, congestion, curtailments, reserve, and even help us respond to system disturbances. Dynamic line ratings can reduce capital investment costs borne by customers. And I'm going to talk about an example of that that's happening today in PJM with Pennsylvania Power and Light's deployment of DLRs on specific projects. Market Monitor for MISO has found that using better ratings in terms of emergency and ambient adjusted ratings above static ratings can lower costs by $150 million over a 2-year period. And that's not even considering the benefits of dynamic line ratings. So let's talk about why it matters a little more about improving reliability and resilience. The next slide. Here we go. And this is a graphic that actually shares some data that on a research project that I was involved with at Southwest Power Pool. It actually zooms in to the dynamic line rating capabilities versus AAR ratings for a specific line. And what you'll see is that there is a period of time where dynamic line ratings are actually below static line ratings. But in reality, the ambient adjusted rating may be too high, well, maybe too low, I apologize, compared to the static rating for about 10% of the time. So let's toggle through these comments. I want to talk about why we modify line ratings based on ambient conditions. It's not new and has been done during emergency conditions in the past. During the bomb cyclone a few years back, New York actually looked at ambient conditions and adjusted the interface limits between New York and New England, actually allowed 200 more megawatts of flow to help address the emergency needs in ISO New England. Let's tab to the next key point, and widespread dynamic line deployment can increase or address a problem of identifying appropriate ratings for use in sudden or long-term absence of major assets. I think that's really important. And the last point I want to make on this slide is that accurate line ratings are more reliable lines. Calculating the true thermal limit for lines informs relay settings, help us protect equipment, and overstating capacity results from inaccurate ratings can be very dangerous and harmful. This is some data on why DLR is more accurate than AAR. And this data is actually from a 345 kV line in western Kansas that was part of a pilot project with Sunflower Electric and Southwest Power Pool. What you can see on here is the amount of time that the DLR rating was below the value indicated by the ambient adjusted ratings. And it goes between 0 and 50% of the time the rating is lower than what actually should be considered safe. If we tab through this, I want to note that the AAR often did not reflect the true near-term transfer capacity of the system, and therefore fails to reflect the true cost of delivering wholesale energy to customers. It's important to note that the wind speed has the highest non-linear impact on conductor rating when the wind is not available to cool the line, and AARs typically do not take into account that fact, which is risky. Let's tab forward to the next slide if we can. You can go on forward. Thanks, Julia. One more. Thank you. The last point I want to make on why it matters is that the Commission has jurisdiction and responsibility to ensure accurate ratings. They have jurisdiction over practices that directly affect the cost of wholesale energy, capacity, and ancillary market services, such as transmission line ratings. It's important for the Commission to ensure that we have the most accurate ratings possible for economic regulatory responsibilities. Just as it was important for the Commission to require available transfer capacity to be accurately calculated and posted to OASIS based on orders 888, 889. What I'd like to do on the next few slides is to go through some of the specific responses to some of the issues that have been raised in the NOPR. Hopefully there'll be some good Q&A that comes out of this. Transmission owners have the ability to disclose nominal ratings and the assumptions of those ratings, and to perform a cost-benefit study of the deployment of DLRs, other congestion mitigation technologies, and or upgrading terminal equipment. And it's important also that the Commission proposes for AAR, DLR can be used as the relevant line rating when evaluating a request for near-term point-to-point service request, for responding to requests for information on the available potential near-term point-to-point transmission service with respect to ATC and other service offerings. Also point that the posting of ATC and other information related to near-term point-to-point service must be made to the OASIS site. The proposal above can also apply to seasonal ratings for long-term service. But I think it's fair to show, and you'll see later, that DLRs is more accurate and probably is the most appropriate rating in many, many cases. Let's go to the next slide and talk to a little bit more of the issues that are raised in the NOPR. The Commission does propose to require that transmission providers use AARs as the relevant transmission line rating when determining whether to curtail or interrupt point-to-point transmission service. DLR could be used in the exact same way. The Commission also proposed to require transmission service providers to implement unique emergency ratings that will be used during post-contingency operations. It's important to note that DLR sensors are capable of providing that kind of data under any circumstance. The Commission is proposing also to prioritize implementation of historically congested lines and interfaces. However, some consideration needs to be given to extrapolating historical constraints and congestions going into the future. We know that congestion moves with time, especially as transmission system capacity is expanded with new transmission lines and upgrades. In addition, the commission proposed to quote, to require ISOs and RTOs to establish, implement systems and procedures necessary to allow transmission owners to electronically update transmission line capabilities on at least an hourly basis. This capability to upgrade line ratings at least hourly is really important and would greatly facilitate the value of dynamic line ratings. So if the commission is going to require this for ambient adjusted ratings, we could leverage that with some more technology that can provide a lot more information about the accurate capacity of the system. Let's move on to our third area of responses to specific issues. AARs can be applied to any facility where ambient weather conditions are a determining factor. It is possible for transmission service providers to determine whether or not power for limit is terminally limited. Terminal limits are prevalent on lots of the systems out there. There was no original expectation that transmission lines would carry anything near the conductor ratings when they were built. But things have changed, and the flows on the chains of system have changed a lot. And we think there's an opportunity to deploy DLRs. The commission is proposing to quote transmission providers to evaluate requests for DRs as well as network load based on seasonal line ratings. That's really important because the summer ratings are typically lower than winter ratings, and sometimes the summer is the most limiting conditions. Let's go forward to the last area of specific issues. The commission has proposed to apply AAR to day ahead as well as real-time markets. And it's possible to use dynamic line ratings the same way. You can actually use them a day ahead or 2 days ahead if you wanted to do that. Increasing accuracy does not increase litigation risk, as some TOs suggest. I think it would be better to have more accurate ratings to use for everybody's benefit and minimize safety and risk. Whether it's AARs or DLRs, the use of accurate line ratings could improve transmission planning as well as operations. Hopefully we can get data from DLR sensors that could be used to help with long-term static ratings used in planning studies. Accurate line ratings can be used by transmission providers when they're assessing network upgrade cost assignments for interconnection customers too. At this point, I'd like to take a little break and see if there's any questions before we get into some real data. Hopefully you'll be interested in some of the graphs and the other information in the rest of this presentation. Julie, do we have any questions we need to address at this point?
There are a few in the Q&A. John has been jumping in and responding to most of them, and Joey as well. So if you want to take any live, we could.
Super.
We could also move on.
Thanks, guys, for doing that. It's really helpful. Let's get through this, and then we'll have some formal questions at the end and additional dialogue. So I want to share some real data and some real case studies and go through experiences that can help us all understand what's going on. So this is real data from an ERCOT transmission line. I think it's a 138 kV line on ERCOT Encore system. And this is based on a project that was funded by the DOE back in 2010 and 11, 12. I think if we tab through this, you'll see some highlights. of this data actually demonstrates the marginal increase in ratings due to AAR versus static line ratings. You can see for this line for this month that the static line rating is about 870 amps to flat rating all hours of the day. You can see the line above that is the AAR rating, which actually follows a diurnal pattern based on the changes in the temperature of the day and night. The top graph is showing the DLR, which can be significantly higher than the static and ambient adjusted ratings based on wind speeds, because the static line rating uses 2 feet per second. Many times wind speeds are much higher than that, creating lots of margin. Sometimes you'll notice, though, occasionally that the dynamic line ratings are actually below the static rating, and the same thing for the ambient adjusted ratings. So there are risks using static line ratings. But I think you can see clearly that dynamic line ratings provides a lot more headroom for many hours of the month compared to ambient adjusted ratings or static. Let's go forward to the next slide, and this is particularly important, I think, for wind farms, especially for generation interconnection ties and leads. Wind curtailments can be problematic if you're using static line ratings or even ambient adjusted ratings. I've been very impressed working with some folks in Rocky Mountain Power Pacific Corp, and they are putting in some pretty big wind projects in southeast Wyoming to facilitate the integration of those wind farms into the grid. They are deploying dynamic line ratings on the generator leads, and that makes total sense. As you can see, that the wind turbine cut-in speed is significantly above what is used for the wind speed assumptions for static line ratings. And if the wind is blowing so that the turbine is generating full output, the cooling on that line is significantly higher than what is used in a static rating. You can see that if you only have 7-mile-an-hour winds, that you're going to get conductor capabilities that are 1.5 times the static ratings based on very slow conservative wind speeds. So my point here is I think you need to look at using DLRs for generator ties for sure, because if the wind's not blowing, you don't really care. But if the wind is blowing, you're getting lots of cooling on that conductor. Let's move forward to the next slide. I want to talk a little bit about some PJM case studies and experiences. And you'll notice on these graphs, which is similar to the other graph I showed earlier, the shake, that the dynamic line rating capabilities on that curve over the period of a year on the 345 kV line in Michigan and Indiana is significantly higher than the ambient adjusted ratings on the left. You'll see that there is a little crossover too at the very end of this graph, where the dynamic line ratings can be too high compared to ambient adjusted and maybe even static ratings. So this is experience on a 345 line that AEP did a project with to collect some data and share. Let's move forward and show how the ratings change with the different methodologies. As you can see, if we tab through this, so this is a typical day, and DLRs typically peak in the mid-afternoon, and DLRs are lowest in the early morning. Why is that? I think we can see that the DLR hourly trends reflect average wind speeds distributions, which are calm in the morning and windy in the afternoon, at least for this location. And that's key, because you're going to want to have additional capacity when the load is picking up in the afternoon. This is the same line and the same research project that shows the ampacities across 6 months of the year, 7 months of the year, for a typical day at average time hour ending. But dynamic line ratings are higher than ambient adjusted ratings on average for all hours of the day and all months of the year. In addition, the DLR is strongest on the windy spring afternoons, which is what you'd expect. And dynamic line ratings are lowest on the calm summer, late night, early morning periods. And that is probably when you're going to hit peak demand is late summer, early evening hours. So does this agree with ambient adjusted methodology? I don't think so. The data doesn't support that. So let's go forward a little bit more to another PJM example. And this is actually a simulation that was done using ProMod in the market efficiency base case back in 2008. So PJM was actually looking at the potential benefits of applying DLR to a specific 500 kV line on their system and see how that affected congestion in the market and other flows on adjacent facilities. One of the key things you'll learn from this case study is that if you focus on just one congested line, it's going to move congestion to another line, and you got to be really careful in not overstating the benefits of dynamic line ratings. So this was real data on a real line that's used in a simulation. And we want to go forward and talk a little bit about the results. So they're focusing on DLR on this 500 kV circuit. And you can see that they can reduce about $11 million worth of savings on that line by applying DLR. And the related transformer has some congestion relieved too. Well, what you see is that the congestion on downstream 230 kV systems can increase so that the net congestion savings for deploying DLR on this 500 kV line is 4.2 million and not necessarily the 11.1 million shown on that specific line, because you have to look at the benefits across the system. Other additional 230 kV lines are going to load up more if you start loading up the 500 kV, and you're going to create additional constraints. And we're going to have to address that. You need to look at the aggregate net benefits of DLR deployment on a system. I've got a couple more slides and then we're going to get into the Q&A. On this slide, I want to thank David Queer at PPL. And this is a recent slide that he shared at the PJM Planning Committee meeting last month. And they are actually deploying DLR on two 230 kV lines in PPL system. They're working with PJM to take full advantage of the line capacity to operate to the real-time ratings and used forecasted ratings in the day-ahead markets. They're continuing to look for additional lines to install equipment on. And I think one of the really important things is the last bullet and the things on the slide here. But looking at using accumulated historical DLR data over time to justify improving static line ratings methodology. So the data they're collecting with these sensors is really important. And they're not just looking at the actual wind speed and the actual capacity of the line over time and going to use that to compare against historical assumptions, which might be 2 feet per second wind speed and 100-degree ambient conditions and 100 degrees C heating on the line. But they're going to leverage these sensors and the algorithms to monitor asset health, and that will help inform investment and maintenance decisions. And supplemental upgrades in PJM are a hot topic, and this equipment will help justify those upgrades. It's hopeful that these DLR projects are going to defer indefinitely 2 projects that are in the PJM current market efficiency window. I think that's it for my prepared remarks. I want to plug a study that we're getting ready to publish, Unlocking the Queue. This is an investigation of how much value we can get out of grid enhancing technologies. And grid enhancing technologies is not just DLR, but is also power flow controllers, as well as topology control and optimization. And we're looking at that under simulated 2025 conditions using actual 2019 and 2020 models, which have been updated to reflect approved transmission upgrades, as well as changes to the resource fleet with additions and retirements, and also considering 9.4 gigawatts of new renewables that have signed IAs in Kansas and Oklahoma. So this study is supposed to go public on February 24th. I'd encourage you to register for this study at the watttransmission.org blog website. I think this study is really important. It'll help us identify the benefits of these technologies, as well as the cost and what the environmental, not just environmental benefits, but production cost savings and jobs and taxes, and that could be realized if we use technology to integrate projects that are ready to go. So I would encourage you to let us know if you have questions about this, but be on the lookout for this report. It's really important. I think that brings me to the conclusion of my prepared remarks. We got about 15, 20 minutes for Q&A. I'd like to introduce the panelists here. We got Joey Alexander with Ampasimon, Jack McCall with Lindsay Systems, as well as John Mormello, Blind Vision. I'd like to, Julie, I don't know if you got some Q&A that we can hit, but I do have one question I'd like to throw out just to start the conversation and to get some feedback from Joey, Jack, and John, and others. So how do we determine, or how would you propose that RTOs or transmission service providers determine where and when dynamic line ratings make sense? So I'd like to just throw that out and see what happens. So thank you for your attention during the prepared remarks. And now we're getting to the good part of the conversation with the experts. Can you unmute?
Hey Jay, this is John.
Jack
I can jump
Joey?
in. Can you guys hear me?
Go for it.
Sure. So
yeah,
it's a great question. Where is that's going to be? At least as it's been identified by FERC, it's looking at the historical market congestion. So seeing in like MISO, PJM, SPP, for example, what lines have posted congestion in the last 5 years, and the FERC NOPR specifically is going to be addressing those lines within a 1 year time period, and then all transmission lines within a 2 year period. So that's a good place to start.
Great. Thanks, John. Anybody else? Joey, Jack, you want to make any remarks on that?
I can make a few remarks. I completely agree with
Please.
John. So yeah, just taking a look at just public information from the working groups from the different ISOs and RTOs. There's a long list of different paths and lines that are incurring millions of dollars per year in congestion costs, but have been incurring those costs for many years, but for various reasons have not been able to be upgraded. And I think if you just take a look at those, there's dozens and dozens and dozens of low-hanging fruit just there.
Thanks, Joey. I appreciate it. I'm going to read some of the questions here. And in the last few months, the SPP, ORWG, and Market Working Group released a study attempting to quantify the benefits of DLRs. However, they made an assumption that the ratings could not be adjusted further once temperatures went below 60 degrees Fahrenheit. I think there's a little confusion here because SPP staffers are focusing on ambient adjusted ratings. And it may be a conservative assumption not to assume that the ambient conditions get below 60 degrees. I think the key thing for ambient adjusted ratings is to make reasonable assumptions about the wind speed. If you look at technical brochures coming out of Seagray and other experts, typically you need to zero out the wind speed assumptions if you're using ambient adjusted ratings. Otherwise, you can get yourself in trouble, and we don't want to overload lines and have safety issue and risk issues. So I think that's really important. That my understanding is that SPP is really focusing on ambient adjusted ratings, even though they may be using the term dynamic line ratings. John or Jack or Joey, have you been involved in any of the SPP discussions?
Hey Jay, it's John. Yeah, I was involved in a couple of the ORWG projects. There's actually a current one going on with SPP looking at DLR and the benefits to the system, and a historical one that we did with AEP as well in the SPP territory. The benefits that we saw from that study showed that 99% of the time, the ratings provided by DLR were higher than the static ratings, which were being compared to at that time. And within a 2-week period of really kicking off that project, we saw that congestion posted 3 times in the real-time balancing market just within that time frame. And all of those times had additional capacity above the static. So essentially, that was really like a fictitious event and didn't need to happen due to the additional capacity that was inherently available and then revealed by the DLR systems. So that might help a little bit.
That's an excellent point, John. That there are cases where there's phantom congestion on the grid that really don't exist in reality if you had accurate ratings. But those assumptions have been internalized, institutionalized, and been used for a long time in rating assets. But we're in the 21st century, and I'd hope we could start using technology and not just make static assumptions about parameters of the weather and conditions that may be ultra conservative. I've got a question from Elliot Roseman I'd like to read. And go ahead, Jack. You got a comment?
No, I was just going to comment on that last exchange there. The observation that DLR ratings were higher 99% of the time is consistent with all of the DLR studies that have been done over the last 20+ years in terms of DLR providing higher ratings 95+% of the time. And in particular, going back to the one slide you had in the presentation, Jay, showing how much additional capacity is provided when you take the wind into account on wind farms and avoiding the need for curtailment. That when you do have high wind conditions, which is producing the maximum amount of wind power, which is where you're most likely to run into curtailment issues, is the time when you most likely have significant additional capacity made available that DLR can quickly reveal. So it all ties together quite consistently with years of experience, and again gets back to exactly what you said, which is we know how to accurately rate lines now. We don't have to make any assumptions anymore, and it's a perfect time to start moving forward in that direction.
Thanks, Jack. Yeah, back in 2006, I was manager of planning at SPP, and we were just starting to talk about wind development in Western SPP. We did some studies that actually looked at correlation of wind speeds and line ratings. And technically the study was supported by the transmission working group. Unfortunately, the transmission owners did not want to change their rating methodology at the time. I think things have changed, and we need to find ways to integrate new renewables to meet accelerated decarbonization goals, and dynamic line ratings is one way to do that. I see a question from Elliot Roseman I'd like to ask the panelists, and then I'll have some comments too after they're done. Can the sensors identify, quote, weak links in the grid that need replacement to de-bottleneck the system? There may be specific older components that limit transfers. Have there been case studies on any utility systems on this? I'd love to hear a panelist comment about
Jay,
thermal limits
if
and
you just go
data and
back to
transparency.
Jay, if you just go back to the one slide that you had earlier, which shows the $11 million benefit provided by DLR, and then how you had to reduce that because
For the
of
PJM sample?
For the PJM, or correct. I mean, that's a perfect example of this. You know, there you go. Every single one of those additional costs where, for example, look at that downstream reactor at 230 kV, that reduced the benefits by $2.7 million. My guess is you could probably replace that downstream reactor for much less than $2.7 million and pick up that additional savings. So there are a lot of benefits. DLR, DLR systems can in general also provide inputs where you can show what the next limiting elements are in a DLR calculation in the system, so that they'll clearly point out, hey, I'm now limiting what my additional capacity is because of the next limiting element in the line. And then the TO or the utility can make the decision as to whether it's economically viable to address that next limiting element and relieve that or release that additional capacity.
Thanks, Jack. That's great.
Yeah, and just to add on to that, those facility ratings in the next limiting or of the next limiting elements are all identified by the utilities as part of their FAC compliance process, the FAC. So those are identified by them and then passed on to the PJMs and other market operators. So I guess in summary, the DLR sensors.
Comment here, and I'd like to ask it.
Oh, sorry, Jay. I was going to say, I guess in summary, those weak links are already identified, I guess is what I was trying to get at. Thanks.
Okay, here's a question from Anthony Daring. In the February 24th report on grid optimization, is there a proposal for how DLRs would be incorporated into planning studies? I think the TOs might advocate for reducing planning ratings in the summer if the DL is lower only 5% of the time. Well, first of all, this was not a look at planning simulations. These are backcasting operation cases to see what could have happened if we had equipment in the field and the capabilities and systems in place to use grid enhancing technologies. I think what PPL is doing is great, and they're going to start collecting dynamic line rating data over time and use it to inform static planning assumptions. That makes so much sense. But we're not looking to change how we plan the system. We need transmission upgrades that are robust, and it's going to take a lot of time to get transmission projects approved, sited, constructed. So the purpose of this study is to look at this bridge in time between today and the actual construction of large network upgrades that could increase the efficiency and deliverability of renewables to markets. Hopefully that helps. Got a comment from Ed Pfeiffer I'd like to read. The comments regarding wind speed and the wind farm output assume that the constrained transmission is proximal to the affected wind farms. That constraint can be miles or states away, nullifying this assumption. So is this a valid DLR AAR assumption? It's a fair comment, Ed. I think the point I wanted to make when I noted the experience in Wyoming with Rocky Mountain Power and Pacific Core is that they are using a radial gin tie, you know, it might be 30, 40 miles long, but it's going into the network, and the rating that they're going to use on that lead is going to be based on dynamic line ratings. And that's premised on tremendous amounts of conductor cooling if the wind farm is generating. When it comes to network issues, I think that's a different, and we got to be more careful and do more analysis. I'd welcome comments from others on that.
Hey, Jay, it's John. Yeah, the direct benefit that you mentioned there is, you know, the proximity is going to be in the order of directly like within a mile, right, for the gen tie line to the wind farm itself. But generally speaking, the lines are nodal, you know, pricing and then zonally component. So the larger wind patterns will be still present across those larger affected areas. So it is worth looking at those generators, and then the line that is actually congesting, even if it is 2 elements or so down on the network, there will likely still be the wind patterns, and wind studies can be done to look at that as well.
Thanks, John. Looks like we might have time for another question or two. I think we've addressed a lot of these, and I appreciate folks putting responses in the Q&A. I think I just want to open it up to the participants and ask them if they have any final closing remarks before we close out this webinar. Appreciate everybody's attention, but I would like to hear from Joey, Jack, and John and what they think we need to do with this NOPR. John, you want to go first?
Sure. I was wondering who you were calling on first. Yeah, happy to close it out. You know, Jay, thanks for putting this together. The data you showed, in my mind, really is a compelling argument to use the most accurate types of ratings that are possible for lines, and that is really going to improve the reliability and the safety of the system. Just given that AARs at times will still show extra reliability when the line actually might not be able to carry that capacity that it is being reported to have. So, you know, we're looking forward to the NOPR coming out. You know, it's going to be about a 60-day comment period that's open now. So mid-March, it should be closing. And then after that, it'll be a year to do AAR or DLR on the lines. And then after that, another 12 months to do it on all lines. So we're looking for, you know, mid-May 2022 for first phased implementations of this. And we're really excited.
Thanks, John. I appreciate you mentioning the time period. Jack, you have any closing remarks?
Yeah, I just wanted to echo that. You know, it's as long as we're undergoing the effort to change the rating methodology or to consider a change in the rating methodology, we should really go for what is going to provide the most accurate real-time methodology that takes into account all of the conditions that actually affect the line rating, and DLR is definitely that mode. So I echo Jonathan's comments.
Great, thanks, Jack. Joey, any closing remarks? And I'm going to close it out.
Sure. Yeah, I'm a very data-driven person, and the thing that's in the forefront of my mind is when we look at systems that we've deployed where we have sensors out on the lines, and we compare the real rating based on the environmental measurements on the line We typically see that the real line rating, at least 2 to 5% of the time, is below the static rating, and can also even be below the ambient adjusted rating, right? Because ambient adjusted ratings are based on data that's not measured on the line. So there's a big risk there. There's potential gains from AAR, but there's also a big risk when you're operating based on data that's not taken at the site. So I think that if we all think about what's the best way to get some gains, to get the most out of existing assets, and do it in a way that's safe for everybody and saves the consumer money off their electric bill at the end of the day. I think that we have to look at, these types of technologies, whether they're, dynamic line rating or topology optimization, all the different grid enhancing technologies that we think FERC should be looking deeply into and considering. So really happy that we have the opportunity to talk with such a large group here, and thanks everyone for joining. I really appreciate it. And thank you, Jay.
Thanks, Joey, and thanks, Jack and John, for your input. I appreciate it. Thanks, everybody, for your questions. We will follow up with you individually if we didn't get a chance to go over it. This recording will be made available. And there are some folks that have expressed interest in PDHs, and we will follow up on that. If you are in need of those, let us know. But we appreciate your time, and hopefully you learned something, but getting a hold of us if you need anything.